Hello and welcome to Frap Talks, where we discuss anything related to modular synthesis with Frap Tools instruments. Today we will start with a question. What do music, bakery and connecting flights have in common? It's timing. Music, bakery and flights are all about events happening at the right moment. In modular synthesis, what defines the timing of our musical events are trigs and gates, which are often called timing pulses. Timing pulses are a specific kind of control voltages. They are called timing because their primary role is to tell the synthesizer when certain things must happen, and they are called pulses because they have only two values, low or high, and because the transition between those two values is almost immediate, like an actual impulse. We use timing pulses to generate musical events, such as notes, melodies, or rhythmic elements. As we said in the introduction, there are two kinds of timing pulses, trigs and gates. And the main difference between them is that gates can have a duration, while trigs are short voltage bursts that usually last just a few milliseconds. So trigs define when a musical event should happen, and gates can define when a musical event should happen, but also for how long. We can use trigs when the musical event we seek doesn't need different duration throughout our piece, such as percussive elements. And if we need to define, for example, the duration of a note, we need a gate. We have said that gate signals can have only two values, low or high. And in the Eurorack world, a voltage is low when it is at 0 volts, and it is high when it is around or above 5 volts. The high or low voltages may differ from one manufacturer to another, but the gates have this thing in common, and it is that their values pretty much remain steady throughout each state. In other words, they output two voltages that are not continuous. And this is the reason why they are called gates, because even in real life, a gate that is just half open doesn't quite serve any purpose. It needs to be either closed or open. Open and closed are in fact some terms that we use when we talk about high or low voltages respectively. A gate is open when we use it to let something happen, and it is closed when it does not. So we said that we use gates to define the timing of our musical events. So we use the transition from the gate low to the gate high to mark the beginning of our musical event, and the time the gate stays high marks its duration, and the transition from the high value back to the low one defines its end. The other kind of timing pulses we talked about, the trig on the other hand, is just a very fast transition from a low value to a high one and back again. So we will cover gates in other episodes of this series, and for now we will focus on the simplest of the timing pulses, the trigs. So in this system here, the main trig generator is the sapel. It is a random voltage generator, so it does pretty much other things, but today we will focus on this one. Sapel has two clocks inside, and a clock is basically a circuit that outputs a regular stream of equally spaced trigs. If we patch a clock output straight into the input of our CGM mixer, we can hear a regular beat or something like that. So it would be daring to call this music, but it is a regular beat, and since a regular beat is rhythm, where there is rhythm there can be music. However, trigs and timing pulses as a whole aren't meant to be used as a sound source, but rather to control the articulation of individual musical events or of the whole composition in case of the clock. In this patch here, we are gonna use Falistri to control the amplitude of our sound source, which is the brainsaw oscillator. If we push the button, we will generate a musical event whose duration will depend on how long we keep the button pressed. We can replace this behavior by patching Sapel's clock output to Falistri's trig or gate input. However, in this way, since a Sapel outputs trigs which do not have any length information, our musical event will be all of the same short length. In In this patch here, Sapel's clock output controls the tempo of our USTA sequencer. CV-A controls the pitch of the brainsaw oscillator, and Gate A triggers an envelope which controls the amplitude, just like in the previous patch. The core principle is pretty much the same, so that if we increase the speed of Sapel's clock output, we will increase the speed of the whole sequence. The brainsaw oscillator has a wavefolder circuit that has harmonic distortion to the sound. However, we can use it as a colored VCA to add dynamics to our patches. We must patch a timing pulse such as Sapel's clock outputs to brainsaw's ping input. The ping circuit internally generates an envelope that opens the wavefolder and closes it with an organic decay. We can rotate the ping decay knob to change the duration of this envelope. We can also patch Sapel's random clock output, set to work in less than mode, to the trig input of one of Falistri's envelope. We then patch this envelope to the wavefolder CV input and adjust its modulation amount. The result is similar yet distinct and provide nice harmonic accents here and there. In this patch here, Sapel's clock output triggers the envelopes that control the amplitude of our sound source. The melody, however, is triggered by the random clock outputs, which moves the playhead of the USTA sequencer forward every now and then. The result is a random melody with a steady pulse. In this patch we are using Fumana to filter some pink noise, and first we need to turn down all the filter levels. Then we'll perform some spectral transferring. Listen what happens when we patch a sawtooth wave to the modulation input. Fumana will transfer its harmonic content to the noise that it's filtering. Now we patch some trigs coming from Sapel straight to the modulation input. The result is a percussive and organic tone with a very natural decay. We can add some variation to the patch by using Sapel's random clock output. At the same time, we can use the main clock output to trigger an envelope on Falistri that we will patch to the parametric scanning controls. Parametric scanning acts as a sort of global modulation of the filter levels. We are not performing spectral transferring anymore with this envelope, but we are just applying more standard CV modulation. There will be other episodes of this series about timing pulses where we will discuss gates and their complex use for creating sequences and more complex musical pieces. So if you want to know more about gates, or if you just found this video useful, please consider subscribing to our channel and keeping in touch with us.